All right, welcome back to day 30 of LeetCode grind. Solve or go home. 30 minutes, solve or go home. Okay. Course schedule. Oh crap! I think I remember something like this. Okay,
No, 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 don't worry about it.
this is the third iteration. Okay, so there are n different courses numbered from 1 to n. A given array of courses and courses I equals duration and last day indicate that the ith course should be taken continuously for duration. Days and must be finished before or on last day. You will start on the first day and you cannot take two or more courses simultaneously. Okay, return the maximum number of courses you can take. Okay, so duration and last day. So that means, so these time frames are like seconds or some shit, or it doesn't
Uh, nah, it's more like it doesn't matter what it is, right?
it doesn't matter.
It's
Okay,
just so look at example one.
yeah, so it's like 100,
So
200.
all right, so if it's 100 and 200, that means you must start before or equal to 100, right?
Mm-hmm.
Because otherwise you won't be able to finish uh, before it reaches the duration. So if you start on day 101, then
Then you can't.
it takes 100 to get through, so it will be 201 by the time it finishes, in which case you cannot finish the course because you don't have enough days.
So basically, what you care about is last day minus duration, and you need that many days to solve to
Uh,
get.
well, kind of. That means you must take it on any day from 0 to 100 if you are to take it.
Day 0 to 1. Oh, so these are. Oh, I see.
So
So you can
the
take these courses in any order you want. There's no.
exactly.
I see.
But once they pass their final date, you won't be able to take it.
I see. So yeah, you can take a later course that's better timing, and then come back to an earlier course, right? Basically.
Right.
Okay. So that's why you need optimization, because you can't just loop through and check.
Well, yeah. So, um, I guess there's several things to unpack here, and I guess um, what you should walk through kind of like what your thought process is and the intuition of like when you should take certain things.
Yes. So okay. So given this constraints, basically what you want to do is you want to maximize the number of courses. So basically, you don't want a super long duration. You want something that
Mm.
no you
Okay, why do you say that? Why do you say that?
because if you're taking a long duration, you can't take other courses. So you want courses with the least amount of duration, so you can fit in more classes.
Um, right, but it's okay. So that's a good idea. However, um, like what it's possible to be able to like let's say Tetris all of them together, and then you go, oh, even the long durations can also
Well,
fit
yeah,
in,
yeah, for
right?
sure. I'm just saying you should prioritize lower durations.
Well, okay. What if you had something like 1,000 and comma 1,000, right? And
Okay.
then like you know 10 and then 1,010 and something like that, right? Like and you have a bunch of those guys, right? Like you don't want to not take the 1,000 even though it's
Well, sure. Yeah, you still want to take it. I
right.
guess what I'm trying to
So
say is you look at that point in time at what your next best option to take is.
yes, and there's a way to organize things such that you never have to worry if you are um if you could have done better, right?
Yeah, so I
So
think I think what you kind of want is like I don't know, like at a given point in time, you can see what courses are still available to complete and
mhm.
what and then yeah, given that like yeah, like basically a list of at any given point what courses can still be complete. And then given that,
Okay, I see.
we want to maximize the
Okay.
number of stuff we can pick from that list.
Okay, good. I like the first idea. So the first idea means at any given time, what else can still be done, right?
Yes.
Okay, so how would you sort it such that you always have this um be increasing?
How would I sort the courses so that I can always have the correct order?
Let's say in the example one, let's say the first element was instead of 100 200, it was 2,300, right?
Mm-hmm.
And uh, and let's say you process that guy first, and you're like, oh, I spent 2,000
Yeah.
time units to reach here, and then now I can't do anything else.
Yeah, because everything's gone. Yeah.
Right.
So
So
I think you want to sort by last day.
okay, good. So if you sort by last day, then I guess the second and third courses will switch, right?
Yes.
You also know that you're kind of building up stuff as you go, right? So
Mm-hmm. So yeah, if you sort by last day and you have that, so you grab the 100, 200 for sure. You want that. That's done. Then you look at the 1,012.50. That's the next one, right? But if you look at that one, if you do that one, you can't do the 200 to 1,300 because then
why?
you're gonna take 1,000 units to hit 12.50, and by the time you hit 12.50,
Oh, no. You're gonna take 1,000 units to hit
1,100.
1,100.
Oh yeah, my bad. Yeah,
Yeah.
1100. Oh, and then
And then
and
you're
oh,
still
you can still do. Okay, yeah, you're right. You're right.
exactly. So basically, it's pretty obvious if you can or cannot take it, right?
Okay, so basically, if you sort by last time, then you check.
Mhm.
You check to see if that course is completable. If it's completable, then you just take it. If not, you move to the next one.
No, well, uh, so I agree with the first part. I do not agree with the second part. But
Oh wait.
okay.
Oh, are you saying if I can't complete this this day, the next day is definitely not completable? That doesn't make sense.
No. That's what I'm saying. I'm saying that the first idea of sort by last day is correct.
Mm-hmm.
The second idea of if you can't do it doesn't mean you're like host, right? There's still a way to possibly save it.
What? How's that possible?
Okay, let's say you. Oh, what the hell?
Oh shit! You have earthquake
Uh,
warning?
I think it's Amber Alert or something. One sec.
Yeah, sounds like it.
All right, sorry.
No props.
Some elderly person is missing,
Oh,
which is not good.
GG's. Yeah, that's bad.
Okay. So back to example one. I guess we can modify it such that we're able to do this, right? So can you write the sorted version of
Sure.
courses below, and then I'll give you an example to extend that.
Okay. Sort it.
I think the second guy is 1,000, right?
Oh, is it? Oh, yeah, you're right. Okay.
Right. So right now, if you were to do this, and so let's say instead of 1,300, it was like 1,250, right?
Sure.
Or no, let's call it 1,299, just so it's different.
Okay.
Okay, so what will happen is you start with 0.
Mhm.
You're coming into the school, right? You're like, oh, I'm gonna add 100 from the first guy, right?
Yeah.
And then you're like, okay, now I'm gonna add 1,000 from the next guy, right?
Okay.
Right. So now you're like, okay, I'm currently at 1,100. If I add 200 to this guy, I will exceed 1,299.
Yeah.
So then what can you do? Do you know you've added 100 and 1,000 so far?
Okay, so maybe you can pop the previous one and check if this one's better.
Right. So can you pop the? So okay. That's a good idea. Is it the previous one or is it the what? What should you store such that you know the best thing to pop?
Well, isn't the best thing to pop? Oh, okay, I see. The best thing to pop is probably the largest unit count. Right?
Exactly, exactly. So you can look at the largest unit, right? And you're like, oh, if I instead put this 200 instead of 1,000, I now instead of 1,100, I'm at like 300, right?
Yeah.
So there's potential other classes that you could be taking, but
Yeah. But
know
in
that
this example, it doesn't help. But
it
then
doesn't help in
yeah,
this
but
example.
then it does
Let's say
help
you
in
had
other scenarios.
right, like let's say you add another comma
Yeah.
like 200 comma like 1,500 or whatever.
Yeah.
Right?
In that case, then you can grab two classes instead of one.
Right, right, right.
Okay, I see. So basically, what we want is to sort it by end date, and then we want a heap,
Okay.
a max heap, and then
Right.
we just pop.
And in Python we don't have max heap, but you can just put the
Yeah,
negative
do
sign
the
in there.
negative. Yep.
That's fine.
So we pop the max heap out, and then we check to see if the or actually okay. So if you pop max heap out, and then you do the next one, that's only a one for one trade. It's not guaranteed to be good.
No, right, right. It's a one for one trade, but you only do that trade if your current duration.
Okay,
Sorry,
yeah,
the
you check to
previous.
see if it's a less timer, and basically that's
Exactly.
worth it,
And
right?
if it's not, then you just put back what you popped.
I see. Okay.
Right. Also, it's possible that like you don't have a heap yet, so then you literally cannot do anything, right?
Yeah, if you have
Like
no
if,
heap, then you don't pop. You just
right, right.
you just gotta keep going.
Basically, I have to skip this class no matter what.
Yeah. So
Right.
basically,
So
basically the algorithm is if it fits, you sits. If it
yes,
doesn't
and if it
sit,
doesn't fit, you see if you have a bigger box that you could
yeah,
get rid of.
then try to get rid of something that is too costly, and then see if you can replace it with better stuff.
Right. Okay. So now can you code
So
this?
wait, so like yeah, so thinking about it greedily, if you're popping the max, you're always gonna be fine, right?
Right, right. So they will never give you a duration that is bigger than last day, right? So that means that's why sorting it in this order is key. If you don't sort it in this order, then you have no idea, right?
Mm-hmm.
Like if you do the 2,000 first and then the 1,000 after, then you have no idea. But if you sort it in this way, you're guaranteed that anything that you've done before works,
Mm-hmm.
and any new one you can say you either decide at that point to keep it or to reduce it or something, right?
Mm-hmm. Sure. Yeah, that makes sense. Okay. So I forgot the lambda sorting because you definitely need lambda sorting for this one because Python
Okay,
sorts
I can walk you
normally
through that
as the
sometime.
first tuple. So
Right.
I do need to do courses equals something. What is it? Sort it,
Yeah, sorted.
and then how do you do the lambda syntax for it? Is it x comma y or
Alright,
something?
so first is the argument of what you want to sort.
Yeah. So it's the courses.
No, not that. What element? Yeah, okay, good. And then comma
Yeah.
key.
Key equals. Is it equal?
Key equals lambda x.
Lambda x or lambda
Yeah,
wait literally lambda x.
yeah.
Okay.
Lambda space x
Okay,
and
space.
colon.
Okay. And then x
And
is
so what do you want to sort by?
we want to sort by the second element. So
Right. So x bracket 1.
okay. And that's it.
So this will sort it ascending by the second element.
Yeah. That's what we want.
Correct.
Okay, let's see. Alright, yeah, that's good. Okay. So given this sorted courses now, alright, so we have a heap. Okay, so we'll do max heap equals, I need import heap queue. Max heap equals array. Okay, so first one. Okay, so we need to keep track of time. Curve time equals 0. Okay. For courses, course and courses if
so each of these is a tuple, by the way. So you should do. Well, I mean, it's up to you. You want to index it afterwards, or you want to
yeah,
state
sure.
duration and
what is it? Duration
and time or something, whatever you want to call it.
Duration last day. What was it? Last day in courses. If last day, wait, so if last day subtract the duration. Oh wait. So I need to check first if I can actually even take this course or not. So to take this course, my current time has to be less. It has to be less than last day minus duration.
Yes.
Yeah. Okay. So if last day minus duration is greater than or equal to current time, then we can just add it straight up.
Hang on. Oh, okay.
Yeah, that's fine, right? Yeah. Because then if 200 minus 100 is greater than 0, so you're good. Then we want to max heap. We know it's heap q dot heap push, and we want to push in. We only care about the duration. But then, wait, if we push in duration, we pop it. Oh yeah, if we push in duration, we just subtract duration back. Okay, that's fine. So we want to push in duration times -1, and then we do current time plus equals duration.
Hang on, the syntax is wrong. So heap push.
Oh, after passing the heap, yeah.
The heap first.
Heap first, yeah. Okay. Okay, so given that, then I increment the time, and then.
Wait. You didn't call it heap. You called it max heap, right?
Oh, yeah, I did. Oops. Okay. So current time plus equals duration. That means at my next iteration of the loop, I'm going to pull down the next course is 1,000 duration, and last is down 250. Down 250 minus duration is 250. 250 is greater than or equal to current time, so it's going to pop that in there too. So my heap will now have 100 and 1,000, and my current time will be 1,200. Yeah, and then
1,100.
Is it? It's 100 plus 1,000. Yeah, 1,100. Then it's gonna come into the next one. So look at 200. Or 1299 minus 200 is 1099, and that's greater than current time. So we can't do this. So we need the else case. Else we do if heap heap q dot heap pop heap max heap. And then we store this as duration. Wait, no. Duration. No, duration is a var that we already used. Okay, let's call it duration saved. Duration removed. Whatever. Okay, duration removed is this. And then we check if we can pop. If we can push. Okay, so we need to check to see if this duration is greater than the next duration. So
okay. But there's something wrong with this duration, right?
What do you mean? Oh, I have to multiply by -1.
Right.
Okay. So then if duration removed greater than, we don't care about equals, right? If it's equals, we can just put it back in. It doesn't matter.
Yeah.
Duration removed greater than duration. Then we want to heap q dot heap pop or heap push max heap duration times -1 current time. Oh, we need a minus equals first. I guess we could do it in one operation. occur time plus equals duration removed plus duration. Right, so negative 1,000. Wait, actually it's not negative, it's 1,000 here. So it needs to be minus equals. So 1,000, it should be minus 1,000 minus 200 is 800. Occur time minus equals 800. Yeah, that should be correct.
Okay.
Okay, so if I do that, it would, and then there's the else heap q dot heap push max heap, and then you just put back duration remove times -1. Okay, so this would have everything handled, but my return case, I'm trying to return the maximum courses I took, so I don't think I need a count. I can just return the length of the heap.
Right.
This should be fine. Okay, so yeah, if it's greater than, I do all this stuff, else I just put it back in. This occur time should reset back to whatever we saved.
Yeah, there's a typo on line 23.
Oh yeah, there is. Okay, I think this is fine.
Okay.
Heap is not defined. Did I call heap again somewhere? Where did I put it? What line is this? 17. Oh yeah. Oops. Tree. That sounds good. All right, let me put in my example. This should be. I think it's 1, 2, 3, 4. Yeah, looks good. Nice. Before the 30-minute limit too.
I mean, if you get the algorithm down, it's coding is very easy, right? Like, so I think it's a huge benefit to be able to think out loud about the algorithm, and then once you nail that down, then coding it is super easy.
In most cases.
Yes.
In most cases, the algo is the hard part. But then, in some cases, the coding is the hard part.
Yeah. I mean, if it's just implement something, then yeah, coding is just literally just coding. But something like this, like if you didn't sort it by time first, and then if you didn't do the heap thing, then you wouldn't. You pretty much be like stuck with it.
Yeah.
Okay. Very good.
Thank you.
Okay.
Wait, do you have time or no?
Yeah, we can do more.
Alright, let's see. I don't know, should I go back and finish that deserialized tree shit?
Yeah, sure.
Oh man, I have no idea how to get it right workings. Yeah, this stuff is like all messed up. I didn't fix it last time. But yeah, I think it was cleaner without the tuples.
Yeah, you don't really need that many support functions. So serialize should be fairly straightforward. Deserialize is the tricky part.
Serialize was not for me. I keep having extra nulls. So okay, let me put back in my old code. I think it was.
Really?
Yeah, it's fine. Let me recode it. So while frontier, I want to node equals frontier pop left. Okay, and then it was if wait, no. It was like if node dot val.
Oh wait, hang on. What is the purpose of tree traversal here?
It's to build the array.
So this is for serialize.
Yeah.
Okay.
Okay, yeah, so I have a frontier with the root. I pop it out, and then I append. Okay, if node, I need to append self.r dot append node dot val, and then it was, I believe it was, I checked to see if left existed. Okay, wait. So it's
So okay, what if not node?
yeah, that one was just, I did self.r dot append none, and then it was, this one was self.r, well, not self.r, it's tree traversal node dot left tree. Oh wait, no, this is BFS. Why am I calling? Why am I doing recursion? This is wrong. Okay, so it's self. It's frontier dot append. Okay, it should append the node dot left.
Yeah, well, the problem with this is that where are you writing these values out to?
What do you mean?
You have to store these guys somewhere, right?
What am I storing?
When you pop these guys or append these guys, what happens? Oh, self.r. Oh, wait.
Yeah, it's self.r is the array with the vowels, and then this is just.
Okay.
So I did this. This semi worked. Wait, I didn't print. Oh, I did print, right? Am I printing? Yeah, right here. So this is semi works in this case, but then I have four extra nuns in the back.
That's fine. You don't care about that. Sure.
Oh, really? I don't know how to. Are you sure you don't care about those? Those might affect stuff.
When would they affect stuff?
Because if you're building a tree, it's gonna think 4 has two
so
nun
the
children.
kid of 4 is gonna be none.
Yeah.
The kid of 5 is gonna be.
Does that, like, does my algorithm, if I do actually set 4 left dot left equals none, it's not gonna break anything, right?
No. First of all, yeah, it's not gonna break it.
Okay, so alright, then
Okay,
yeah, I
so
had
your
serialize
serialize
working
is
then.
fine.
It's just deserialize is way too confusing. I have no idea how to do it.
Yeah. So, in deserialize, the key is to kind of see that for every node, you want to pop 2 different things, right? So inside of your serial thing, for each node, the next 2 are the children.
Say it again.
So okay, look at your 1, 2, 3, none, 4, 5.
Mm-hmm. Yeah.
So in the layer 1, you have 1 is the root.
Yeah.
Right? So then you know that the next 2 values here are the kids of 1.
Yeah, but how do I handle that?
I mean,
So I'm looping through the array.
You just pop twice.
So but then at the next level, you know those 2 are the children of 2. But how do you know? How does it know?
No, then you could do a DFS. Oh, sorry, BFS. Again, right?
So, okay, at each stage so we need to have a stack, or not a stack, a queue that preserves which children you're pointing at.
No, okay, so look at it this way, right? Let's say you have a BFS, and you put 1 in there.
Yeah.
Right.
Yeah, I put 1. Yep.
Right. If you put 1 in there, then when you pop the next 2, it's gonna be 2 and 3. So 1 dot left is 2, 1 dot right is 3.
Yes.
Right. So for each of these guys, you should put them back in.
Put them back into the frontier. Okay.
Right, and 3 goes back in.
Okay, and then
when you do a 2 dot pop, when you do frontier dot pop, you have 2. So now you pop twice again, right?
Also, every time you pop from the frontier, you pop from the result array. And
exactly.
Oh, I see.
And the next 2 become the kids of.
Yo, that makes so much sense. How come I couldn't think of that? Okay, so we want two poppers. We want a frontier for the.
Data
We don't
first.
want two poppers. We have a frontier to pop from, but we also want to pop from self.r. So we want
Yes, exactly.
yeah. So self.r is an
Well,
array.
now you have no dependency on data though, so that part is a little wonky,
What
right?
do you mean by no dependency on data?
So deserialize is supposed to take data as argument. So technically, your serialize is technically wrong because you're supposed to return like uh, the string form of self.r.
Oh, I can do that, right? I just cast the array into a string, right?
Uh, kind of.
Wait, then what are you looking for, Alan? I
I
don't
think
know.
you want comma dot join self.r.
Comma dot comma
Quotes
yeah
comma.
dot join. Okay, and then and then we want to access the data here, right? So we want um, nodes r equals data or something, or
No,
we're
so
just
you
popping
you
data,
just
right?
do you just do data dot split.
On comma.
Yeah, on comma. So
So
whatever you did before,
nodes
you should just.
equals this. Alright, let me print that to make sure that even works first. Let's do a pass here. It doesn't like that stuff. Expected string instance int
Oh,
found.
I see. So none is not a string.
Oh, so I have to actually do quotes no.
You can do quote none or something, or that. Sure.
Wait, what? Or what? It doesn't work.
Oh, you also need to append. Oh, sorry. No dot val has to be a string now. Everything has to be a string.
Wait, what do you mean no dot val?
3 lines above where your cursor is.
Oh, no dot val? So, all
Yeah,
these have to
that's an
become
int.
strings?
Yeah.
Okay, so uh, just cast string to them.
Yeah.
Wait, if I pass in, no, I can't. I don't think I can pass in. What you call it? Quote none, because then it's gonna break my algorithm. Because my algorithm checks to see if
Wait. Frontier. What?
what
No, hang on.
does this work? String has no attribute val, but I'm not calling it on string. I'm casting string on it.
No. So your frontier should your
Oh,
2021
this
should
one
not be.
shouldn't be string. These are actual nodes. We shouldn't do that. It's only the val part. Oops. Yeah, that should be fine. Okay, so yeah, so none type found. Okay, so I need to do. All right, fine. I can do none in quotes here, but then if node, so it should be if node not equals none. Wait, actually,
No, it'll never be none.
no. Okay, so wait a minute.
A frontier never has any strings.
Oh, wait, we don't care. Okay. We're passing. Okay, this is a self R. This one doesn't matter. Yeah, this should be
Yeah, it doesn't
fine.
matter.
Then why is it saying a none type of something? Okay, there we go.
Because it was not cast.
Okay, that's fine. Okay, 1, 2, 3, none. Okay, that's all good. So do nodes dot split print nodes. Okay, now now it's in array format. Okay, that's fine. So given that,
So now you have to recast them.
yeah,
Well, I mean, you can do it however you want, but.
is it int parentheses? Does that work?
Hmm?
Is it just int parentheses?
You can. Well, if it's not none, then you. If it is none, then it's none.
Yeah, but I mean like literally that's how you cast to int, right?
Yeah, you can cast it, but you have to check if it's not none.
Yeah, okay, that's fine. So frontier is empty, and then we want to append the first one to it. So it should be so front if nodes 0 not equal none, frontier dot append int node 0. Okay, and then we want it to while frontier. Okay, so we have this here. So we want to pop. Okay, so we want to append the nodes, but we also want to pop. Okay, I see. Okay, so we pop this. We pop it from the array, and then we put it into the frontier. And then yeah, each operation is popping from frontier and adding back to the frontier after popping from the R. So it should be fun. Okay. So while frontier exists, we want to say frontier. Okay, so node equals frontier dot pop. Okay, so the problem is there should be a DQ. So we pop that. Okay, so we have the node, and technically the array should be a DQ, right? Okay, so let's go back to it. Oh, we can just cast it as a DQ. Can we cast DQ after the data.split?
Yeah, you can do that.
Okay.
You do a DQ of data.split.
Yeah, okay. So that's fine. Okay, so I pop the left. That means I have the first node. And then I check to see. Okay, so I popped the first node. My current self.r still has it. So I should probably pop it from here before I wait. Do I pop it from here first? So if I pop out the first node, I put in the Trojans into the frontier, but then I also want to pop it from the R. Yeah, every operation that I pop from frontier, I need to also pop from R. So the question is, do I need to do it here or do I need to do it earlier? I think it's fine just to do it here. So self.r that pop left. Okay, so given that, now I have both my array self.r now doesn't have 1, and my frontier lost that 1. So now frontier is empty.
Wait, hang on.
No. Yeah, this has to be done outside. This, because this will, we need to call this twice after we pop the Trojans.
Okay, sure. Yeah, that's fine.
Oh wait.
Well, it's also not self.r, it's self.nodes. Or nodes.
True. Okay.
Oh, I see what you're doing.
Oh wait.
Okay. Technically self.r should not exist. But you have it, so I guess this does work.
Wait, it shouldn't exist? Oh, because you just need to return it here, right? You don't need to do all that crap.
And then what the hell is the point of nodes? If self.r.
Well, nodes is the data, because you just have to use data instead. And that's what, yeah, so technically self.r is useless. It's, okay, fine. So instead of self.r here, let's get rid of this. We're going to encode true traversal with the array. So we're going to call it data, I guess, whatever. Data equals array. I'm going to pass in to data here. And then we're just going to do data.append here. And that's fine. It's going to return data here. And we want to return data here. That should be the same code.
Okay.
Yeah, that looks the same. 1, 2, 3, no. Yeah, that's fine. Okay. So back to this. Okay, so if I pop the first one, that's the head. But how do I know each consecutive one I need to pop exactly two? How do I know the first one is only pop one and everything else is pop two? So instead,
Well,
instead of doing the frontier.pop on the head, we want to just, we don't need to append it at all to the frontier.
oh, you do. Otherwise, it's empty.
No, but we want to start with the two children because each
No.
operation is always
Wait,
a double pop, right? Oh wait, no.
What are you
The
talking about?
popping of the children corresponds to. Yeah,
The DFS.
never mind. That's right. Okay. So popping this indicates that I want to pop two from the data, and those are the children of this current node.
Exactly.
Okay, yeah, my bad. Okay, so we want nodes. Okay, so child one equals nodes that pop left, and then child two equals nodes that pop left. And we want to cast this as a string as an int if I can. So just do the operation afterwards. Okay, so given this, my node popped left. What is the pop left on frontier? Frontier currently is
1.
Yeah, okay, so I need to actually create the node. So I need to create a new tree. Tree is none. Tree equals tree node. And then wait. Yeah, that's fine. And then tree.
I feel like that should happen earlier.
Oh, the building of this?
Frontier should already have a tree if there's not none.
So, so you're, instead of popping it int, you're popping in the nodes?
Right.
Is that fine?
Then you can immediately append it if
Yeah, I guess that's fine. Okay, so if I do it outside. Okay, so frontier shouldn't append the int. It should append the tree. Okay, so if. Okay, yeah, I already checked that. Okay, so it should be tree equals tree node int of nodes 0, and then I just append tree. Okay, so if I do that, I pop it, and then I do this. Okay, if child 1 not equals none, node dot left equals int, tree node int of child 1. If child 2 not equals none, node dot right equals tree node int child 2. Okay, and then after that, since I popped left twice on nodes, no, that's fine. Okay, yeah, so I now need to append these to the frontier. Frontier dot append child 1. Okay, so this order is preserved because I'm popping 2 first and then 3. And when I pop left, it pops 2 out.
This is not quite right.
Wait, what's wrong with it?
Child 1 is not type node.
Wait, what?
child one. What is the type of child one and child two?
Child one is a string.
Right. And what is the type of what you popped? What is the type of node?
What do you mean?
What type is node?
Node is a tree.
Right. So why are you adding a string to a tree node?
I'm not.
Why are you adding string to an array that has trees?
Wait. Why am I adding string to an array that has trees? When did I do that?
Line 64 and 65.
Oh. Oh wait. Oops. This should be node dot left and node dot right.
Right, but shouldn't it only occur if child one is not none? Then you'll have a none type that is a tree. It's not right.
No, wait. Okay, wait. Is that wrong? Having a none type?
No, that part's right.
No, I mean like, is it wrong to add to append a none? I guess you don't
Yes,
want
because then none that left doesn't exist.
Okay, that's fine. Let me just do it like that. Okay, so I have that stuff.
Okay, then what happens if child one is none?
If child one is none, then node dot left should be none.
Yeah, but that's already by default.
Yeah, then we don't have to do anything.
Right, okay.
Okay. So yeah, so this would append the children, and then the children come back in and you pop it, and then it gets the next set of nodes. Yeah, each pops 2, and then puts it back in, and then
Okay.
wait. Child pop left, and then you this appends to the front. Okay, yeah. So the next one would be the 3 that you pop, and then the next 2 on the nodes array will reply to child 2. Okay, so that's fine. And then when you pop the children of child 1, yeah, that should be okay.
Okay. And then what's your return?
Return tree. Wait, that's what they want, right? Deserialize. Where is it? I have no idea what they want. Return type tree node. Yeah, so it should be fine. Okay, cool. Looks fine. Oof. Okay, something wrong here. Invalid literal for int with base 10 empty quotes.
Okay.
Oh, so it can't equal empty quotes. How did I get empty quotes in here anyway? What the hell did it do?
Data was nothing.
Oh, it was empty. Oh shit. I didn't handle that case. Let's see. It does a DQ of empty string. I see. Okay. So wait a minute. So okay. So that means my joining on this.
That's fine. You can just check the length of a split. It should be nothing.
Yeah. So if nodes is empty, we don't want to do any of this crap.
Correct.
We turn none. Yeah, that's fine. If nodes, then we do all of this logic. It's still doing that shit. Wait. Invalid literal when tree equals. Wait, so it's saying there's nodes? Why is there nodes? I think it is that empty string. Yeah, it has empty string. So it has to be, we can't do this part if it's empty. So I need to check to see if data is empty. Wait, where did that empty string come from? Empty string. So data is empty array. I traverse this stuff, and it's saying data has a comma there. Oh, not a comma, but like an empty string. No, it's empty. Data's empty. So does comma join on empty set return an empty quote? Okay, so maybe if not data, if data, return this, else return none. Wait, no.
You're gonna run into problems. None cannot be split.
Yeah, but I thought we checked to see if it existed first. Oh, I see. No, we just straight up called split on it. Okay, so that means if nodes, if you're splitting on an empty thing, it's apparently auto creating an array with just empty quotes. But then, okay, wait, so why not just, okay, if data, and then do all of this inside that, else you're just going to return empty. Yeah, that's fine. Alright, cool.
Alright, good job.
Alright, do you want to do more or are you good?
It's on you, dude. I don't care.
Alright, yeah, give me a sec. I need to respond real quick. Alright, let's do another questiones. Wait, why am I going to problems? Where's my Explorer? Explorer reporting.
Hello.
Oh, who that? Someone here?
Me.
Oh, I thought someone joined.
Okay.
How come Danner's no play?
Drop on. Alright.
GG's. Okay, did we do, I think we did coin change, right?
But yeah, we're still in the easy question.
No, this is medium. Medium, rare. I don't think I did jump game. You wanna try jump game? Do you know this one?
No, but we can figure it out.
About longest increasing subsequence. You do that one?
It's fine, dude. We can figure it out whatever.
Alright, let's check it out. Okay, given an integer array nums, return the length of the longest strictly increasing subsequence. A subsequence is a sequence that can be derived from an array by deleting some or no elements without changing the order of the remaining elements. For example, 3627 is a subsequence of the array 0, 3, 1, 6, 2, 2, 7. Okay, it says by deleting some or no elements without changing. Okay, so basically they removed 1 and 2 and then they made that. Why is that valid? Doesn't make any sense. Okay, return the longest strictly increasing. How's it strictly increasing? Doesn't make sense. Oh, that's just an example of a subsequence. It's not saying that's correct, right? Okay. Okay, so in this case, I guess it's this one. Wait, no, it's not. You delete the 0 here. You delete the 3 here. So it's 0, 1, 2, 3, I guess. That's why this one is 4. Okay. So algorithm approaches here, okay? What the hell do I want to do here? Okay, so I guess starting off, you check your current index, you look at it, and you look at the next index. If it's good, you keep going. As long as it's increasing, you keep going. And then if the second it decreases, you check to see if you can delete the previous unit and see if that one fits this one. But if it doesn't fit this one, then yeah, so if you delete the previous one and you put this one in and it still doesn't fit, then you leave. Then what? Then you're done. You're dead, right? Well, no, you can also delete this one too, right? Shit, that's too confusing. That's too much logic. How do I know when to delete?
I don't know if you're deleting stuff.
Well, delete as in like removing it, right? You're not really removing it per se. Like you just need a data structure that is handling the return of that list that is strictly increasing. So I was thinking like maybe popping stuff out, but then I don't know if it handles all the edge cases. Because if you're looking at 0, 1, 0, 3, 2, 3, so you start at 0, and you get the one that's good, and you see 0. The 0 doesn't fit, so you just throw it away, I guess. You just ignore it. But how do you know if that 0 could have made your thing longer if you remove some other unit? I don't know. I don't know what to do. What to do? 36. That's not even correct. So 237 101. 25 is good. But then yeah, how do you know what? So you start with 10. You go to 9. Obviously, that's bad already. So your current longest is 1. Then you just skip that shit. So wait, is the algorithm basically you see if you can replace the previous one with your current one? If you can't replace it, you just ditch that subsequence and just move on? Wait, no, you can't. You can't full ditch it because what if you delete 2 and then it makes a perfect chain? You can't. You can't know that.
Okay. What's the inputs?
They got the 10, 9, 2, 5, 3, 7, 1, 0, 1.
No, I know. But how long can it be?
Oh, up to 2,500.
Oh, then this is brute forceable, kind of, right?
Well, that's just the length, right? Oh, length is, yeah, that's not bad then. Brute forceable is probably doable, I think, but it's gonna
All
be
right,
slow.
let's start with that then, because then intuitively that should be the simplest thing to do.
Okay, so if you're brute forcing, what exactly are you doing?
Well, you can do DP, right? And you can say that at any point you can have uh, a subsequence of size 1.
Yeah, subsequent size one is guaranteed.
Right. So then by default that will be your return value, right?
Sure. That doesn't help me traverse the array though. How do I
Oh
know?
well, traversing the array is fine. We
How
don't
do I
need
know
that.
when to
So what?
chop stuff? How do I know when to chop stuff?
What is chop stuff?
Like, how do you know what stuff you're not putting into the subsequence?
No, it's fine. So okay, so just initialize with 1 for each index.
One for each index. Wait, oh, you're making a DP array?
Right. And I think for bigger inputs, this might time out. Even for this input, it might time out because you might have to do n squared.
Okay.
Okay. So now you have to go through each index, right?
Sure, but what are we doing with this? Okay, so oh, I see what you're doing. So you're storing the longest subsequence at each index.
Right.
I see. So if at index one, at index zero, it's still just one, but at index one, it's also one because 10 and 9 doesn't make a bigger one.
Right. So if 10 and 9 were swapped, then it would be 2 at
Yeah.
index 1.
Okay, I see what you mean. Okay. Yeah, okay, I think I know what you're doing here. Okay, so yeah, okay. So basically, I need to compare with the previous index to see if it's less than. If it's less than, I increase my subsequence. Otherwise, it's not. I just leave it alone. Yeah, I increase. Yeah, I increase by the previous index, and then I increment by one if it's good. Otherwise, I just take the previous. Okay, I think that's what. Yeah. So for what is this? What is this input? Oh, it's just nums. Okay, for nums. Okay, but I want to compare. No, I don't need to compare.
I think you want the index.
Do we need the index? Alright, I guess maybe we do need the index. Okay, so for this index enumerate ones. Let's start it with index 1 for it. Okay, so wait, let me print this real quick. Does it still start at 0? And it does
And
0.
it feels like a 0.
Okay, so that's kind of wrong.
Oh, so you should just do range. Don't enumerate.
range len nums. Wait, no. Do you do len still, or is it just range straight up?
Range or length, yeah.
Okay, and then if you do index num, it still gets both of them? Does that still work?
No.
That doesn't work, right?
No. Range is a range.
Yeah, okay, so yeah, you can't act. So you only have the index, right?
This is also still wrong because
Why is this wrong?
length of nums 1 to end is nums minus 1. So you're still going to get the wrong index. If you want to count from 1 to length nums, you should do range of 1 comma length nums.
Oh, right. Yeah. That makes sense. Okay, so then I can do. Alright, so I need to check if nums I is greater than nums I plus 1 or I minus 1. dp of I equals dp of I minus 1 plus 1.
Kind of, but not quite.
Isn't this?
Right? Technically, it's any index before this guy.
Wait, what do you mean by any? Oh.
Let's say you had.
Oh, because you can cut off dudes, right?
Yeah.
Shit. Okay. So, that's why you're saying n squared runtime.
Right.
So I have to loop through everything beforehand.
Right.
So basically, okay. So I have to do for I don't know, for counts in dp up to, let's say, what is it? 1. It should be, wait. If you do index 1, 2, that means it starts with index 0, right? But no. You have to do 0 to I, right? This is 0 I plus 1. Print count. Let's see what this looks like. Okay, that's so many of them. Is that even correct? That looks like it printed too much.
Well, you're doing both loops, so.
Yeah, that's why.
What do you expect?
Alright, well, let me print it outside then. Let's just do I, let's say I is 0. 0 plus 1 is 1. So from 0 to 1. Oh, shit. So 0 to I plus 1. Is it just I or is it I plus 1? Oh wait, simple way. Let's just do this. No, this should be I. This should be len dp. Seven and 8. 1, 2, 3, 4, 5, 6, 7, 8. So it should be this one. Okay, so you should go to len dp. So if I do len dp, and my loop is up to len nums. Nums is equivalent to dp. So if I start at 1 index, len nums, dp minus. So it should issue. Okay, so wait. I'm just freaking confusing myself. I don't think. Yeah, okay, I think it's just the subarray. Okay, so wait. So for counts in dp 0 to I. So I starts at 1. So 0 to 1. The array of 0 to 1 is 0 and 1, right? So it should be 2 i's. We don't want the current I. I think it should be I minus. Wait, no. What is dp of 0 to 0? I think that's empty, right? Yeah, that's empty. So we don't want that. We need at least this. Okay, yeah, that's fine. Okay, so we want for counts in dp of 0 to I. Yeah, okay. So given that, we need to check if any of these are less than the current. If any of these are less than the current, then we need to use the maximum of these and add 1 to it to make the current index.
Right.
Okay, so we need a max, basically. Max equals 0. Max count 0. We want to do max counts equals max of max count and counts if it is less. Okay, so if nums I is greater than shit, what is it? I think it's nums count. Wait, no. Wait. So I need to check to see if this number is greater than any of the previous numbers, but using the dp we don't have the numbers. So I think, okay, so if I'm looking through dp, maybe I shouldn't be looking through here, maybe I should be looking through nums. It should be for num and nums 0 to I. If nums I is greater than nums num. Oh no, we need the enumeration. Shit, we need the indexing of this. So this should be enumerate. Okay, so given this index and num of enumerate, if this num, if nums I is greater than any of these nums, okay, so if it's greater than, we want to set max count equals to the max of max count and dp of index. Nums I is greater than num. That's fine, okay. Yeah, because then this would loop through every num previously seen. Okay. And the max count would be set to the max of that, and then I do dp of I equals max count. Oh, this should be outside the loop. Yeah, so this loop was finished, and then I set it. And then this loop loops through every single num. This one just loops through every single num before that num. That seems like a huge ass runtime. Does that work? Nope, it does not work. Something is wrong. Alright, so I guess I'll print stuff. Okay, so print index. This is print TP also. Why does this get set to 0? How's the max count is 0? Or this and this? Oh, it's because of this. If num's I is greater than num, I set it. Else I don't set it. So this should be. Okay, max count is set between this. Okay, but then that's only if the nums. Oh wait a minute. This seems wrong. I have to plus 1 to this. Should be plus 1. But then that still doesn't save this thing, because if none of these nums are greater than, it's not going to trigger this case, and it's just going to set. So max count should be dp of index. Okay, does that solve this issues? Oh, index is not even accounted for. Hold up. No, it should be dp of I. Yeah, that looks a lot better. Is this one? Yeah, that one looks good too. Is this one 1? Yeah, that one. This works. Just see if it times out. Yeah, I think it's gonna time out. Oh, give a wrong answer actually. I guess I messed up somewhere. Let's get my prints back. What is wrong with this one? 5, 3, 6. How does it go down? How is that even possible? It went down.
Oh. Because the last element wasn't what was used.
Wait, what do you mean? Oh, I have to return the max of this. It's not always the last index, right?
Right.
Oh shit. Okay. Does that solve shit? Oh, wow. No time limit. You just accepted it.
Oh, you look at the inputs.
Yeah,
Global and n squared.
28% speed though. Yeah, I get. Yeah, this is. I guess it's enough speed to because there's not much inputs. But then this is probably not optimized, right?
Right.
Is there? Do you know the optimized solution to this?
Not really.
Okay.
I mean, you can probably do it. I mean, the fact that they're saying log n means that you probably should put in like an error source somewhere.
Bin search. Wait, where did they put log n? Oh, right here. Yeah, I don't know. Maybe you sort it, but store the indexing somewhere? Does that even help? If you sorted this and you had the indexes still, then you can check to see which indexes are like a good. I don't know. I have no idea. Alright, are you done?
Up to you.
Let me do more. Zigzag level order. I've never done this before. Let's try this out. Given the root of binary tree, return a zigzag order traversal of its nodes values, i.e. from left to right, then right to left, then for the next level, and alternate between. From left to right, then right to left for the next level.
Oh, what happened?
Wait, what? What's up?
Oh, I think I dropped by accident. So. Hello.
Yeah, hello, what's up?
Yeah. We good?
Yeah. Do you see my stuff still?
Yes.
Okay, cool. Yeah, I'm looking at zigzag. It looks like you do left to right, then right to left for the next level, and then the level after you do left to right again. So you're just constantly switching the DFS, like I guess nature of it. But then DFS might be harder to handle. If you do a BFS, I think it's easier to flip them.
Right. Let's do that then.
Okay.
What the heck?
What the hell, Alphaz?
Sorry.
Yeah, okay. Alright, so BFS. BFS frontier equals no root. Okay, so we want a DQ of this. Okay, so we want like a flag that determines when I'm going left to right and when I'm going right to left, right? Or no, I could. No. So I need to be able to track which level I'm on, and each. I think I can just do like if it's even level, then I do that. Odd level, I do that. So
Yeah.
I don't need
you
a
don't need
flag.
to or anything.
Okay. So to track the levels, what am I tracking for levels? I guess I could just pass a tuple of the node and the level. That's pretty simple. Yeah, I think I'll do that. Okay, so I'm gonna do root comma 0. So that means even I'm going to be doing left to right. Yeah, because the tree, the root will do left to right, and then this is level 1, it's going to do right to left. Okay, that's fine. So EQ of this, while frontier, I'm going to pop it, node equals frontier dot pop left. Okay, we want node comma level. Okay, so given that, we check. So if wait, traversal. What did I want? What's the return value? Oh, it's an array. Right, left to right output. It looks like it's an array. Yeah, so we just need. Okay, we need ret equals this. Then we want ret dot append node dot val. Okay. Oh yeah, no, we need a dictionary for the level so we know which we're appending to. Because this array by itself. Okay, yeah. So I technically don't need a tuple. I just need a dictionary. But then, oh, if I don't do a tuple, how do I keep track of what level I'm on? Yeah, I think I need both. Okay, so I need. Okay, so yeah, instead of this, I would just put into dictionary at the end. I would just build out the ret from the dictionary. So level dict was this. I guess it starts with 0. Okay, that's fine. So if level in dict, I want to do dict level dot append node dot val. Okay, that's fine. Else dict level equals new array with node dot val. Okay, and then I want to append the children to the frontier. Okay, so frontier dot append node dot left. Frontier dot append node dot right. Oh, and I need to append as a tuple, so I need to append level plus 1. Level plus 1. Okay, that should be fine. And then each level I will have the node.val. Okay, wait, no, this is not correct yet because I still didn't do the flag switching. So, okay, if it's even, I want to do left to right. So
what does that matter? Because you can also do it at the end from the dictionary.
Oh, just like reverse the array or some shit?
Sure.
Yeah, that works. Okay. So, yeah, for val in dict dot val, is it dot values? Is that what it was? Oh no, actually we want both. We want the key.
Items. Right.
Is it dot items?
Yeah.
Wait, does that give me key and val?
Mm-hmm.
Okay, cool. So if k, yeah,
Then you need k comma v or something.
I did do that. I think you're a bit delayed. K mod 2 equals 0, 0. Then we want to do ret dot append v. Else ret.append sorted v reverse equals true, and then return ret. I think that is good, unless I made a mistake somewhere. Type is not iterable. Level indict. Why is that not iterable? What is level is a integer. What? If level, what's wrong with this? Oh, it's level dict. I'm an idiot. Crap. Okay. None type does not have a value. Okay, so I didn't check for that apparently. When does that even happen? I put in the, oh, so sometimes the root is null. Wait, no, it's the children. If I append, so I should only append if there is a child. Yes. If node.left.
No, the problem is before this.
Is it?
Mm-hmm.
Wait, what's wrong with it? Okay, let me see. Node val. Oh, so it's saying this thing, but node. I'm pop. No, because it's technically not before this, but also it is technically before this. Because then, like, if I do it here, that means I don't append the nose, but it looks like I already appended nose. That's why it's getting nose from here, right? So I shouldn't even append nose, right?
No, well, you should be if node, then do all that shit.
Yeah, that does work. Wait, if node. Yeah, but because in there, so let's say the node exists, but it had left node.left is a null. So that will, yeah, this will catch that, but yeah, okay, fine. And V is a list. Why is this not? Oh shit! No. Oops. Should be that. Okay, my beds. It looks fine. Let's do the empty and the one case. Okay, this one empty is wrong. Okay, so because I put in a DQ of the roots to start, but that means root was null, right? So if roots, then I do this. Ret. I need to move ret outside. Okay, that's fine. Oh, that's not fine. What can I do? What is wrong with this? This looks exact same thing. Oh, there's a 1-5 here. The 5-1 here. Why? So oh, so reverse doesn't work. I actually have to do it properly. I see. Okay, so I can't do this. I'll just make it red append V, and then I have to fix it up here. Okay, let me try this. Okay. Okay, so I have to check here. Okay, so I'm appending the node.left and the node.right. So I need to append them in a different order here. Oh wait, where is it? The dictionary. So when I'm doing zigzag, so 3 goes in first, 9, 20 goes in, because that's the children, and then it should go, it went right to left, so it went 15 first and then 7, so that looks like it's the children, not the val. So if these get flipped around, wait, no, I think I can just do it for the val. The children, yeah, the children comes in fine, 20 comes in, it does 9 first. It should, left to right is the nodes getting placed in, right? Oh wait, shit. So 9, 20, and then it went 15, 7. So in that case, if I pop 15 out, this would be left to right again, but then I should be popping 15 before 7. I shouldn't be popping 7 before 15. So yeah, I think I need to place them into the frontier that way. I can't, it's not, this thing doesn't matter. Yeah, okay, so, alright, so if level mod 2 equals to 0, do this, else just the opposite. That should do it. No, it doesn't do it. Why not? Why does this not do it? What the hell? Wait a minute. Oh wait, am I doing this? Oh, because the root. Okay, so this is opposite. This should be down here. And this should be up there. Okay, but it looks like this one is still wrong, and this one's still wrong. Okay, so does this have to get flipped too? Why is this doing this? Okay, so if I popped out 4, if I pop out 4, okay, wait, no. It pops out 2 first. 0, 2, 4. What the hell? 0, 4. Shit. Oh my god, I'm confusing myself. Oh. 0, 2, 4. So the tree looks like this. Okay, so first level I pop 0, that's fine. And then it switches to zigzag, so I should be popping 4 and then 2. But then, oh, I don't think it's popping them in the wrong order, it's just printing them in the wrong order. So it's still popping in the normal order, I think. So instead of this, it should still be the left, right. It's just the appending to the dictionary should be the opposite direction. Wait, that doesn't make any sense. You only have access to one at a time. Shit. Okay. Oh, I think you need to do call reverse on every 2 parts of the array. So I have to separate the array into multiple segments and call reverse on every part and then append them back together. I think. Right, if I did this back, if k is equals to 0, because then this is 8, 6. Wait, no, because this one looks like it's in correct position, but this one isn't. What the hell? Alright, let me print. Oh, reverse is reversing the numbers. That's not how it should work. That's why this is wrong. God damn it. Okay. You're not reversing the order. You're reversing. Shit. What the hell is going on? This is confusing now. Okay, so 0, 4, 2, 1, 3, negative 1, yeah, and then 8, 6, 1, 5. 8, 6, 1, 5. Okay, yeah. So I appended it to the array as 5, 1, 6, 8. 5, 1, 6, 8. Yeah. Okay, so it's because they're ints. That's why it's reversing. But I want to reverse the order of the array. I don't want. Oh, because this is trying to sort the numbers. Yeah. So I don't want to sort it. I just want to literally just reverse the array. So what, is there? I mean, I could just do it myself. List for num in rets v negative 1. Wait, no, isn't it just v negative 1? No, is it negative 1 that way? Negative 1 this way? I don't remember. Oh no, it doesn't do it. Oh wait, what is it? No, this doesn't do it. What is? What the hell? Okay, I can just loop it then. Whatever. Reversed v equals this for in v.
I think you should print level dict just to see what's there before you do anything.
I think it's
If it's
fine.
already wrong, then you can't.
No, it's correct. Yeah, 5, 1, 6, 8 is the normal ordering. Where is my thing? Yeah. I just have to reverse the number. It's because when you call sorted, it's doing on integer sorting. So, but we don't want that. We just want position sorting, position reversing. We don't want number reversing. So I just need shit. So yeah. So these are ints, right? 5, 1, 6, 8. If you call sorted and reverse on this, it's gonna sort. Yeah, that's what I'm saying. How do you call it? How do you call reverse by itself without sorting it?
Colon -1.
What was it?
Colon -1.
Like that? Is it v colon negative 1? Like that?
In the brackets.
Okay. See, that's what I was just looking for. I was just gonna code it myself. Yeah, there we go. No, that's good. Alright, we good. That was literally why. Okay, yeah, because I was calling sorted on integers, and it's trying to sort the integers, which is completely wrong. We just want to reverse.
Oh, you don't want to sort anything.
Yeah, I didn't know. I messed up. Okay, that's fine. Alright, you done?
Up to you, dude.
Damn, how much time do you have? Alright. One more. Intersection of two linked lists. I don't know if I want to do a linked list. Increasing triplet subsequence. Okay, it says given an integer array numbers, return true if there exists a triple of indices I, j, k such that I less than j less than k and nums I less than nums j less than nums k. If there's no such index, return false. Okay, so it's saying this is true because 1, 2, and 3 is a triplet, 2, 3, 4, and 3, 4 is 5, right? But this is not correct. This one has 3, 4, 5 is invalid. 0, 4, and 6. Okay, as long as it's increasing. Yeah, okay. I get the question. Okay, so basically, is this literally just sliding window, Alan? Is sliding window too slow?
I guess so.
Is sliding window too slow? I think it's fine, right? You check 1, 2, 3, right? And then if that's good, you're done. If it's not good, then you check 3, 4, 2, 3, 4. If that's good, you're done. If not, and you check that until you get to the end, right? Is that too slow? Or is that fine?
Okay, so what would your loops be?
So my loops is no, it's a while loop. While k is less than len of nums, then I'm gonna have I equals at 0 to start, j equals 1, and k equals 2, and then increment all 3 at the same time. So like I equals 0, j equals 1, k equals 2, while k less than len nums. So then this would return false by default, and then if k so if nums I is less than nums j and nums j is less than nums k, return true, and that's it. Oh, not that's it. You have to increment all. So I plus equals 1, j plus equals 1, k plus equals 1. I think that's fine. I don't know if it's too slow though. Oh, apparently it's wrong here. Why is it wrong here? So 2100. Where is the skip sequence here? How does this work? That doesn't make any sense. Triplet of indices. Oh, that's why. It's not necessarily one apart. It can be any apart. Oh, okay. That's so
right.
This does not work at all then. Never mind. Okay. Oh, damn it. Hmm. Two, three, 1, 2, 3, 4, 5, You have no idea.
Think about this.
JK. Do you microwave in food?
No.
No.
Okay.
IJK. Can be any indexing as long as it's strictly increasing. So how does that work? Do I have to generate all the possible combinations of indexes? No, that's probably too much runtime.
I don't think you need to. Trying to figure out what the hell is going on. Okay, I see.
I don't see. How do you,
Decipher what the hell I did in the past.
what do you see?
Okay, so for something to be a increasing triplet subsequence, right?
Sure.
Then you must find some number that is bigger than some number to the left of it and smaller than some number to the right of it.
Okay.
Right. So okay, I see. So in the first example, right?
Yeah.
Numbers that are bigger than some number to the left of it are 2, 3, 4, and 5.
Yeah.
And then in the second example, the numbers that are bigger than the number to the left of it are nothing.
Okay.
And then in the third example, numbers that are bigger than the numbers to the left of it are a 5 and the
Well, 4 is in 6.
4 and 6.
Mhm.
5, 4, and 6, right?
Yeah.
Right. So 5, 4, and 6 are now candidates for being
The subsequence.
like a subsequent middle value.
Mm-hmm.
So you do the same analysis, but going from the right and getting numbers that are smaller, or sorry, smaller than something to the right of it, right? You'll see that in the first example, 2, 3, and so we have 2, 3, 4, 5 coming from the left,
Yeah.
and then we have 1, 2, 3, 4 coming from the right.
1, 2, 3, 4 from the right. Okay.
All right. Well, any of 2, 3, and 4, which is the overlap between those two things, are potential candidates for middle of the triplet.
Okay.
So because now you have the intersection between left and right is size greater than 0, then you know that this is true.
Intersection is greater than 0? What do you mean
Right.
by that?
So coming from the left,
Yeah.
2, 3, 4, and 5 are bigger than something smaller than them
Okay.
from the left. Right. So that's the left subset, and 1, 2, 3, and 4 is the right subset, and the intersection between 2, 3, 4, 5 and 1, 2, 3, 4 is 2, 3, and 4, which is more than nothing.
Oh, wait, okay. You said coming from the right side, it's 2, 3, and 4. You said.
No, coming from the right side, it's 1, 2, 3, and 4.
That mean wait. So when you say that, that means those four numbers are less than 5, right?
No, for those 4 numbers, there is some number bigger than them on the right of them.
Oh, okay. And then the opposite direction is 2, 3, 4, 5, where on the left side of them there's a number that's smaller than them.
Correct.
Okay, sure. And then you're trying to
And
find
so,
the
for example,
intersection between these two sets.
right, because that ensures you have a middle number.
So if intersection exists, then you're good.
Right.
Do you have to check intersection length to make sure it's 3?
No, it doesn't have to be 3. It could be 1. It could be 2. Anything that's not 0.
Oh, as long as intersection exists, that means you're guaranteed to have a set.
Yes.
Right. Okay, cool. Okay. But, okay.
So example 2, obviously it's 0 intersects 0, so
Yeah.
that's nothing.
Okay, sure.
Then example 3, you'll see 5, 4, 6 from the left,
Mm-hmm.
right? And you'll see, I guess 4
5,
and 5
1,
on the
and
right.
1. Doesn't 1 count too?
That. Oh, yeah, 1, yeah, 1, 5, and 4, and 0. I guess 1, 5, 4, 0.
Yeah. Okay, and then if you do an intersection on that, then you just get 4, right?
5 and 4 both are fine.
Okay.
So which would be the array, like, like any of them, 0, 4, 6, 1, 4, 6. 1, 5, 6.
I see. Okay, yeah. So as long as this intersection exists, that means you can build it.
Yes.
Okay, so the only thing you care about is if the intersection exists, and you should return true. You don't care. The question is coding going from the left and going from the right, right?
Yeah.
So in that case, if you're going from the left, that means you want to see everything that is bigger than. You want the set of numbers that is bigger, that all has something bigger than your starting number, right, or something like that.
Mm-hmm.
Wait, is it always starting? I guess it is always starting. So you only care about the starting number and the last number when you're going from left and right. Is that true?
Wait, hang on. Is that true? Well, 3, 4, 5 is valid, but also I guess 1,
1, 2,
4,
3 is
5
valid.
is also valid.
One,
Right.
what? Yeah, 1, 2, 4, 1, 2, 5. Any of these work. There's way too many combinations in the first one that work.
1, 2, 5. 1, 2, 5 works.
Yeah.
3, 4, 5 works. Okay. Okay, then maybe you want to keep some kind of like maximum that you decrease, and then some minimum that you increase.
Maximum that you increase, minimum that you decrease. For what? For what purpose?
To do a sweep without having to find it again.
Not sure what you mean. What are you using the max to sweep with? How does that work?
Right. Okay, so let's say you go from left to right, and then you're like, okay, if it's bigger than the previous value that you've seen so far, you add that index.
Okay.
Right. So let's say your minimum at the beginning is like, you know,
0.
well, probably like infinity or something, right?
Oh, okay, yeah, sure.
Right. So if it's infinity, and then you're starting with example one, let's say, like, okay, is one, uh, okay, so at the beginning, one is not going to be smaller than, or sorry, one is not going to be bigger than infinity.
Yeah.
So you set the minimum to be the minimum of one and infinity, which is one,
Okay.
right?
Yeah.
So then now in the second thing, you're like, oh, two is bigger than one. Two is bigger than your current minimum, right?
Yeah.
So two is a candidate for something larger.
So you put that into your set,
Right.
and then do you check the minimum again, or you just keep going?
Right, right. So let's say instead of at position two it was zero instead, right?
Uh-huh.
Zero is not going to be smaller than it's not going to be bigger than your minimum, so it's not going to be a candidate, but it changes your minimum to zero now.
Oh, I see. So basically, when you're sweeping through, you want to update your min from the left side, and when you're sweeping from the right side, you want to update your max.
Right, right. And anytime you find something bigger than your minimum, that means you know that that is part of an increasing subsequence.
Yeah. So anything that's bigger than your minimum, you add to your set.
Right. Oh, I mean, technically, we don't have to. Okay, you can just set the minimum to be the first value or the last value, or the first value, and the maximum to be last value, and then you can go from one onwards, or you can do.
Wait, yeah, that's what I was asking. So if you're doing from first and last, is that guaranteed to work? Why does that guarantee working?
Why doesn't it work?
No, I don't know. I don't know how to prove that, but I'm assuming you're doing something there that allows that to.
Well, I mean, the algorithm makes sense, right? Like
You're
say
checking
if
all the
you found something
numbers.
smaller,
Yeah,
if you find something smaller, you're comparing against that new thing. If you find something larger, then you have something that is a candidate for a, a middle of the sequence.
sure. Okay, I mean, I can trust that. All right, so you're okay. So you're saying okay. So left num equals nums 0. Right num equals nums -1. Now let's just do if nums first. Okay, so given that, I want to loop through from the left side. So for num in nums of 1 forward,
Mm-hmm.
if then we want the left set, the set, right set. We just want the indexes, right? No, we want the actual numbers. It doesn't matter if we put index or numbers. It's just the same.
It kind of matters because let's say you have two different numbers, which are different indices,
Oh,
but
right.
that
So yeah, we care about indices. Okay. Alright, that's fine. Let's just do index num of enumerates. So left set should okay, yeah, that's fine. Yeah, okay. So if
also this doesn't work because your index is going to start at zero.
oh my god, alright, fine. Range. Do range. Okay. And then we do if nums oh no, if just num if num wait no, we don't have this, yeah. So if nums I is greater than left num. Then we do left set at add I. And that's it. And then for we want the opposite direction for range. I think it is nums -1. Range len. If I do the opposite thing for, do I do it len of this comma 0, or is it 0? Is it still 0 comma that? Does this work?
Comma 0 will work.
Oh really? So the range is from start to backwards, right?
Right.
But how does it know? How does it know if you're decrementing the index or not?
Comma -1.
Oh, so it's not 0. It's -1.
No. So you can do left bound, right bound, and then how many to skip by.
Oh, I see. So, but default is +1.
Oh, you need 0 there.
I put 0 back. Is default +1?
Yes.
Okay. So 0 is when I exit. We want to exit at 1, right? We don't want to do 0 again. Yeah, that's fine. Okay. If nums of I, just j, is less than.
I don't think that does what you think it does.
What does this do?
Because you're still gonna get the first element of nums reversed, which you already have.
Wait,
right num.
No, why would I get it? I'm starting from the back.
Yeah, you're starting from the back. But you already took that.
Oh, so I need starting from the back, but I also need to -1 from it. How do you start from? So is it -2? -2 is it?
Oh, I see what you... No. So colon -1 means do everything, but move 1 backwards every time. So that's why it's reversed.
Oh. Okay, then...
So colon -2 just means you skip every other one backwards.
Okay, so instead of doing that, we want... I don't know this magic Python syntax. I could just do it regular mode. Len of nums minus... Wait, so len of nums will get me the exact end. So I want to -1. No, -2.
Well, the other way to do this is to reverse nums and then just iterate through that. That's should look exactly like lines 11 through 14.
Okay, so nums equals nums.
I would not change the array.
It's fine. We don't need it, right? Fine. Okay, if nums j is less than right num, and we want right set, let's add j.
Well, you have to add something else. It can't be j.
Oh, it's because we reversed the indexing. Shit, this is why you don't reverse indexing. Why would we reverse it? We should have just did it normal way.
Rather than do it the normal way.
Yeah, this is too confusing. Alright. Okay. I'm just gonna go back. Index equals 0. Oh no, it was land. Wait. Doesn't work, right? I'm gonna do that. Yeah, whatever. I just need 2 bars for it. It's fine. Yeah. No, I can use this. I just need a count. Index equals nums lenums minus 2. So then I want to add index, and then I want to decrement it. That should give me the right index. Yeah, that should be fine. And then I check if left set and right set. That means if it exists. Wait, I can just do return left set and right set. Because then if it's empty, if there's nothing, it's gonna be empty, and this should be false, right?
It's gonna be a set. It's not gonna be a truth value. The other thing is you don't update your left and right numbers.
What do you mean? You said I don't have to update them.
What?
Isn't that what you said earlier?
What if something is not bigger than your first number, but is bigger than like your second number?
What if something's not bigger than your first number, but bigger than your second number? Yeah, that's what I'm saying. You needed that min and max thing.
Yeah. When did I say you don't need to do that?
I remember you saying you didn't need that. I was like, okay, fine. All right, so we do need that. Okay, that's fine. Oh, shit. Okay, so. Okay. Min equals min. What is this float? Infinite or some shit? Okay, so if.
No, you don't. Okay, you don't need that part. What the hell are you doing here?
You just said I need the min and max.
Your min is currently left num. You should update the left num whenever you find a new one.
Oh, yeah, I can do that. Okay, so if it's not greater, why is this spacing incredibly incorrect? Okay. Wait, so if it's greater than left num, then I just add it, but I don't need to update it. If it's greater, that means it's definitely not gonna be smaller, so I don't need to update it. So only update in else case. Okay. Okay. And you're saying this returns a set only? Okay, so intersection equals.
I don't know. You give it the second example, see what happens.
Really? Okay. 5, 4, 3, 2 rows. It does work.
Okay, then it's probably fine.
Nope, it's not fine. What is this? Two, 4, -2, -3. There's no 3 sets here at all. But then this might be an intersection. Is there an intersection? Let me print it out. One and 0 and 1. So it's saying index 0. Oh, no, its left set is this. Okay, left set is 1. Left set is 1. Index 1. Okay, so that because this is bigger than 2. And this side is 4 is bigger than. Yeah, these numbers are bigger than these numbers. So this algo doesn't work? Two, 4, -2, -3. Yeah, there's no triplet here that works.
Why is 0 and 1 in here?
Because 4 is bigger than -2 and -3.
No, but then you should look for smaller.
What do you mean look for smaller?
For this sequence to work, the value to the left of the right num should be smaller than.
Yeah, it is
left.
smaller.
-2 is not smaller than -3.
-2. Yeah.
So why is right set giving you this?
No. The indexing is not talking about this. The indexes that have bigger is the 2 and the 4. It's 0 and 1.
Why are we looking for bigger?
Are we looking for? No, it's supposed to be smaller. It says if nums j is smaller than right num. So right num is you start -3, right? And then no, you start -2. So -2 is not smaller than right num. So right num is now the max of right num, and that. So it's right num is now -2. Right?
Keep in mind you're using nums reversed.
Sure. Does that change anything?
So why don't you print it out?
Okay.
Wait, what the hell? No, using nums, not nums reversed.
Oh, right here. That's probably why. Yeah, that is why. Okay. What? Nope, there's more mistakes. influence.
Okay, my question to you is why are you using nums in 21 and then nums reversed in like?
Okay, I didn't see that one either. That should do it. Okay, cool. Yeah, I wasn't intentionally using nums. I just copied the method and forgot to replace it.
Right.
All right, I guess that's it.
All right.
All right, thanks. Bye.